In this video, we're going to look at Chapter 1, Section C on Venn diagrams. Remember that we've been looking at number sets and interval notation. So for the moment, I want you to consider only the real numbers. Okay, and we're going to call this our universal set. Now the universal set can be represented visually using a rectangle or a box. Now let's consider a few other sets. We have set A, which has elements 2, 3, 5, set B, which has elements 1, 2, 3, 4, 5, 6, and 7, and we have set C, which has elements 3, 5, and 8. Now remember that the box represents the universal set, which in this case is all real numbers. We can also use circles to represent the sets in green. For instance, this circle will be set B. And the numbers that are in B are 2, 3, 5, 1, 6, 7, and 4. Notice that the numbers, all of the elements of set A, are also within set B. Therefore, we call A a subset of B. And we can use this notation to represent that A is a subset of B. Notice that C is not a subset of B because we have the element 8. So if we want to represent this on our diagram, we need to draw new circles. So let's draw another circle for set A. So here we have set A, and we notice that it includes the elements 2, 3, 5, as well as set B includes the elements 2, 3, 5. We can also draw another circle that represents set C, and in this case, we need to add the letter 8 outside of set B, but still within the circle for C. So let's go ahead and move my letter B because it's a little confusing. Looks like I can't move the letter B, so I moved the circle for C down a little bit. But what we've drawn here is a Venn diagram. And Venn diagrams are really just visual representations of number sets. And what we can see is the universal set, so all the elements that we're considering, which in this case are all the real numbers. We can see subsets within the, or sets within the universal set, like sets A, B, and C. And we can see that set A is a subset of set B because all of the elements in A are also included in B. So here we have a simple Venn diagram, and I'm going to use it to introduce one more concept, and that's the concept of complementary sets, or the complement of a set. In this case, we want to look at the complement of set S. Remember that we have the universal set, and that set S is within the universal set. The complement of set S uses notation like this. We have S apostrophe, which represents all of the elements outside of S. And using interval notation, we can define the complement of set S. And that is all numbers x such that x is a member of the universal set, but x is not a member of set S. This is probably visually more or easier to understand by looking at the Venn diagram. So let's put a few numbers in here. Let's say that set S contains 1, 2, and 4, and the universal set also contains 3 and 5. So really, the universal set contains the numbers 1, 2, 3, 4, 5 because they're all within the universal set. Set S only contains the numbers 1, 2, and 4 because they're the only numbers within the circle. Now the complement of set S, or what we call S prime, are all the numbers that are within the box but outside the circle. So in this case, S prime is going to equal simply 3 and 5. So let's look at an example problem. Let's say that we have a universal set that includes the elements 0, 1, 2, 3, 4, 5, 6, 7. And we have another set, E, that includes the elements 2, 3, 5, 7. The first thing that we want to do is list the set of E prime, or the complement of E. Again, the complement of E is all of the elements that are included in the universal set but are not included in E. So we see that in E we have 2, we have 3, we have 5, and we have 7. So what's left over is our complement of set E. So we have 0, 1, 4, and 6. Now we can represent this on a Venn diagram where we have set E inside and the universal set inside the box. So within set E, we have 2, 3, 5, and 7. And all the numbers that are outside the circle but still within the box are 0, 1, 4, and 6. So this is E prime. And if we take a look at all the numbers within inside the box, we should have the universal set. Okay, let's look at one more example problem really quickly. We have the universal set U, and we have sets A and sets B, and we want to represent them on a Venn diagram. So the first thing that we notice is that set U consists of all the integers between 0 and 12, including 0 and 12. We also notice that sets A and B share a few numbers, 3 and 7. So we need to draw two circles that overlap because they share some elements. Right? So we can list set A and set B, and we know that set A and set B both have 3 and 7. So those two elements need to go within both circles. In set A, then, I have 2, 5, and 11, and in set B I have 1, 6, and 8. And then outside those two circles are all the other integers between 0 and 12 that are not included, which would be 0, 4, 9, 10, and 12. And you can do a quick check to make sure we've included all the integers from 0 to 12.